Welcome to today's podcast on visual inspection for data-driven quality. I'm here today with Capgemini and IBM to talk about how we use computer vision to improve quality in the manufacturing environment. I'm here with Satheesh Sebastian, a solution COE architect who leads our Columbia Dev Center, and John Groff, North American Industry 4.0 lead for IBM. Gentlemen, thank you so much for joining me, and I'm looking forward to talking about how visual inspection enables better quality detection, especially quality defect detection in station. So John, maybe you could tell us a little bit about the broader view of AI-based computer vision systems and how they work in the manufacturing environment.
Absolutely, Daniel. Thank you for having me on this. So when we talk about AI visual inspection, there's four parts to it, right? The first part is creating a data set. You can teach the system, to identify when a product's been put together correctly and when it has not been put together correctly, right? The next thing you need to do after you've created those data sets, and to give you an example, the other day I took an iPhone battery and I looked at the battery from the perspective of, is it plugged in or not plugged in terms of, is it being powered? Is there an indicator light on that says it's fully charged or not fully charged? But you have to prepare the data by labeling each one of those, right? So that's labeling, that's the second piece. Then you train the model, right? And there's several image classifications around that. You can do image classification, you can do object detection, or you can do action detection, right? And each one of those has some algorithmic models built for this to learn from, such that when you put it in play, it can make those detections as to whether a product has been assembled correctly or not. So Satheesh, is there anything that I missed that you may want to add to this?
I think you have covered.
Okay, Daniel, anything from your side?
Yeah, no, that's a fascinating review, and it really does encompass many more input signals than just the visual detection. I know in working with the University of South Carolina and their advanced manufacturing lab, Satheesh, you and your team have focused on the visual inspection. It seemed like John's description was pretty complicated. There's a lot going on. How have we made this something that's a little bit more tangible and easy to get to, so that we can get to that stage for implementation that John was just referring to?
First of all, thank you, Daniel, having me here. So the data-driven quality visual inspection solution we built on IBM Maximo visual inspection tool. So the solution was leveraging the 5G technologies, using the smartphones to capture the images, and using the cloud to analyze those images and produce the output. One of the key features of our solution is the provision of a dashboard view for manufacturing or assembly stations, plants, and for the entire enterprise. This dashboard provides a centralized interface for users to view and act upon quality improvements. Either they identify a defect or improve their operational efficiency of workforce. It offers a real-time insight and visibility into the quality status, enabling informed decision-making and prompt actions to enhance overall product quality. By combining these advanced image analytics using the IBM Maximo visual inspection and the cloud technologies and the intuitive dashboard views, our DDQ visual inspection solution enables the customer to streamline their quality control process, identify defects early, and improve overall customer satisfaction.
What I think about, Satheesh, specifically around this, right, is what we're trying to do here is what IBM calls the 0D model, right? And that's zero defects, zero downtime, right? And visual inspection certainly has the zero defect squarely in its crosshairs, right? So one of the things that I think about when I'm thinking about manufacturing is the farther the product is away from the manufacturing line, the more expensive it is to do rework, right? So the idea around visual inspection is to capture a defect as it's in process, right? Because it becomes a very easy fix. To give an example, let's say you're assembling, let's say a bulldozer, right? And you're doing something in the lower powertrain, which is usually one of the first things that gets assembled in a bulldozer. If you wait until after the bulldozer rolls off of the superhighway, the problem is you got to disassemble most of the bulldozer to get to the corrective action around the defect. So it becomes much more expensive than if you have it, still in that, I'll call it undercarriage mode, that you're doing assembly such that you can take corrective action.
And it sounds like this is a really valuable tool on the manufacturing floor for that quality assurance. John, have you seen this work in any real world examples that you'd like to talk to us about?
The one that comes to mind is Ford has brought this into their plants, right? So they're actually using it in assembly. And again, as Satheesh had mentioned, right, trying to correct it at station obviously is the least impactful, least costly repair. So part of what inspection can do is alert, right, immediately that there is a defect detection, right? So such that the technician can take advantage of trying to fix it then, right? If somehow it gets down to the end of the line, as I mentioned earlier, right, there may be some disassembly, reassembly to correct the defect. And then as Satheesh said, for Ford, once it gets out to the dealer, now they have essentially a warranty issue as basically the way that they try to handle this, which means the dealer is going to affect the repair themselves, and then Ford's going to have to pay for that. And then the other even worse scenario, right, is if it gets into field, right, and you have a warranty situation, which to Satheesh's point, and I agree with him wholeheartedly, now you're getting into customer satisfaction issues, right? There's nothing worse than having a new car that you've got to go take back because it has a problem with it, right? And that certainly will have a fairly significant impact on customer satisfaction.
So important to catch that defect in station. Can you guys help me understand, and John, as an Industry 4.0 lead, we've been talking about Industry 4.0 for a long time. Some of that's gotten onto the plant floor, some of it hasn't. The things that I've seen previously around visual inspection seem to be very infrastructure intensive. A lot of wires, a lot of cameras, a lot of cages, takes a lot of training, a lot of time. And now with Satheesh's solution, with this wireless 5G option, is this going to accelerate the adoption of these kinds of tools on the shop floor?
Well, that's a great question, Daniel. And again, I spent, before I got into working at IBM and servicing the manufacturing industry, I was in manufacturing for about 26 years. And I think the biggest problems that I saw anecdotally were data was in such a disarray and not accessible, right, in the plant. If you could access it, you had to do some translation on the data to make it usable into data sets that provided leverage. I think with this inspection solution, because you're bringing in a brand new set of data, it's already pre-configured, right, to be able to grab insights out of it. And then also, we've applied our algorithms and AI to it, right, to be able to drive value from those insights. And then obviously with the Capgemini solution from a reporting perspective, it adds yet another layer of value onto this. So I see it as probably the easiest way to start trying to claw some value out of the plants in terms of efficiency, specifically in the quality area.
And Satheesh, your system really marries operational technology with information technology to provide that holistic view of what's going on in the shop floor. Can you talk a little bit about how we've implemented this and how we've worked with the University of South Carolina and John Ward to demonstrate this to clients?
What we hear from customers, right, especially for manufacturing factories, bringing a new solution, the adoption rates are very low. So the beauty of the solution is you don't need to exactly what you pointed out earlier. You don't need to lay new wires or connectivities and then putting some systems there. It is so easy to deploy, right? Using mobile technologies, using private 5G technology to actually capture all the data from the factory floor and send to a cloud to do the analysis.
That's fantastic. And I think that it seems to me that this visual inspection solution generating a good bit of new data and pulling that data into a larger system, right? Because like John was saying earlier, it can be camera data, it could be acoustic data, maybe infrared or LiDAR data. So all of this data is pulling, is giving us an opportunity to create a rich set of digital twins. So it ladders up into a much bigger discussion.
That is correct. That is correct. I think the visual inspection is one portion of it, right? If you consider quality or your plant floor, there are a lot of data comes in different forms. So Capgemini has a data-driven quality solution, which is a bigger umbrella, which can help to improve the quality on the plant floor in both through telemetry data using the sensors or using the manual detection, and on top of that, the visual inspection, right? So that helps to give them like real-time defect detection details, and also like they can react to those defects very immediately.
Got it. That makes a lot of sense. And that the real-time nature of this, it's also moving around some pretty big media files. So is there a need to move towards the private 5G as opposed to a standard Wi-Fi connection?
Exactly. I think that's a very, very good point, right? For example, if you want to like large amount of data, using the traditional bandwidth will not be like sometimes sufficient, right? So you want to get a better, faster bandwidth, and that can help you to actually like transfer the data in a faster manner. And I think that's exactly like the private 5G comes in a play. So we can leverage those advanced networking technologies to actually like transfer the data very quickly and do a quick analysis and produce the result very, very quick in a short period of time.
That's a very exciting program. As we think about this, John, in terms of another real world use case, do you have something in mind that could really solidify or crystallize the way that somebody's used this visual inspection system?
Actually, I have several examples. And again, I'm going to try to do this in such a way that it shows the versatility, right, of what the inspection solution looks like, right? One of them is a fairly significant European automobile manufacturer looking at wheels, believe it or not, right? Not only, and when you think about wheels going on a car, right, the first thing that I would think about is making sure that the lug nuts are all on and tight, right, which is certainly one of the defect components that you can look at, right? The other is to make sure that the wheels themselves and tires themselves don't have any scratches or cuts in the case of a tire, or scratching, or if they've been painted for any reason, right, that there's no anomalies in the paint or anything like that, right? So visual inspection helps from that perspective. In this particular case, the guys saw about a 16% improvement in quality control by inspecting wheels, specifically lug nuts and again, scratches on wheels and tires as they put those on the car. Another European automotive manufacturer where they have the front fascia to the bumper, right? It typically includes the headlights, turn signals, daytime driving lights, so on and so forth in this bumper cover, right? And what they were really looking for was to make sure that the connections were all in place before they put that bumper cover on. So again, another one of these things, I think in that particular case, there was somewhere between a 25 and 30% improvement in quality, which again, when you start running numbers against it, as Satheesh is recommending with his reporting system, then the savings become very real very quickly.
So that's what we're talking about with this kind of system, is not only being able to detect the defects in station, but do it at a rate and at a percentage that has a meaningful impact on the overall quality and the bottom line. Visual inspection solution for data defect detection in manufacturing environments is really great because it's a low-cost, high-value solution, and it's a great starting point, especially for small teams that may not have data scientists, to accomplish in hours what used to take months to get to a viable defect detection solution using computer vision with AI and ML. John and Satheesh, I want to thank you both for your time today. This is an incredibly exciting topic as we look to what's next in the Industrial 4.0 landscape. We look to include wireless technologies, computer vision, AI, and ML, and we look to training and partnerships to make sure that the next generation of engineers is conversant in all of these tools and capabilities. So thank you very much, Satheesh. Thank you, John. Thank you for your time today, and thank you, audience, for listening in. If you have any further questions, please don't hesitate to contact us, and we'd be happy to walk you through our demo or talk to you about your particular situation.
Thank you, Daniel.
Thank you, Daniel.